Okay, good morning. I'm Dr. David A. Paget, and today we are um, hosting Earth Week at the Tennessee State University Geographic Information Sciences Lab. And the main event for the day will be my students sharing their map demonstrations. So that will happen in a few moments. So we will have several groups presenting today. The first group will be, first two groups will be pre-service teachers who have completed the exercise that I will share with you now. So, at the end of March, a couple of weeks ago, the class, all the students participated in a globe outdoor atmosphere protocol exercise where we collected data. And so the pre-service teachers, they were required to complete the exercise that you see on the screen. So they took the data, and this exercise is part of the pre-service teachers' globe certification, their protocol. So they took the data from the globe atmosphere protocol sheets and just entered them into this form, the date, the time, and their current temperature reading, 9 surface temperature readings in degrees Celsius, and then they were to enter those data first at our first site, which is the Old Courtyard Northwest Corner, our first site at Tennessee State University's partnership. And so the first go around in terms of data entry, they used the desktop entry system. And then after they successfully completed the desktop entry of the data that we collected outside, they then went to the second site, which was the Old Courtyard Lawn site. And for the Old Courtyard Lawn site, they entered the data using the Globe Observer app. It gave them the opportunity to do the data entry via both the desktop method and then using the app. And I wanted the pre-service teachers to do the desktop method first because in all likelihood, that's what they're going to be doing. In previous iterations of this exercise, at the back end, the students really said that they found using the desktop entry system easier than using the app. But they did get a chance to use the app, same data. All of them did a really good job of making sure the date was correct, so that came out correctly. And then they got the satellite match. So they got the satellite match. The satellite match was to be pasted here. And then they had to go through, find their data in the Globe data visualization system. So this gave them good practice at doing that. And then they had to take screen caps of their data visualizations and just paste them here, 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 there. And then they had to answer a series of questions pertaining to their data outcomes. And so without any further delay, so I'm going to step aside now, and I am going to pull up the completed work. So the first group will be Nori, Jones, Hedden, and Smith. And so they will come forward. I'll pull up the globe site. I'm already logged in as me. Maybe I should log out. Maybe I should log out. Maybe I should. It'd be simpler if I just stay logged in. We'll see if we have to log in. Yeah, the data visualization should work either way. Okay, so my students are going to come up to the front of the classroom. So that is Smith, Hedden, Jones, Nori. The camera is up there. And you'll just follow my instructions. You'll introduce yourself, your name, your major, and where you're from. And then I will walk you through the process. So I will step aside here. And the students will come forward. Again, you'll introduce yourselves, name, major, where you're from, and then I'll walk you through the rest. So we need Smith, Hedden, Jones, V, and Nori. Moving down. So just, yeah, the camera's up there. It's right there. So you can just introduce yourself, your major, your name, and maybe where you're from.
My name is Vickery Jones. My major is political science. Actually from Nashville.
My name is Erinique Nori. I'm a early child education major from Memphis, Tennessee.
Okay, so one of you is going to be the pilot, and so you have to use the keyboard. Okay, so you're on the Globe page, so go to Globe data, visualize data. Good, scroll down, enter the visualization system. Okay, very good. So we're going to, go over to where it's, get your, right there. Oh, y'all know what you're doing. Let's see if you all know how to find your data. You already done it there. So the layers, of course, we did atmosphere, and then check off the various air temperature. Good. Oh, there's a other member of your group. So, Mr. Smith, you just look into the camera and just hit that camera. Introduce yourself.
All right. I'm Avery Smith. I'm an early childhood education major.
And you're from, where are you from?
I am from Chattanooga, Tennessee.
Okay, so your group members are pulling up your data. So the students are now using the Globe data visualization system. Yeah, so we got surface temperature, so click on that, and then we will see surface temperature. You get the clouds, see the clouds. Yeah, you got clouds. Okay, yeah, I should have more confidence. All right, hit submit. And then you're going to have to change that date to one, over the date is the slider bar. See up in the top, right? Yeah. Date. And we went out, I think that was what, the 29th? Yeah, 29th. Okay, now zoom in. We'll have to give it a second. Zoom in, zoom. Let's see. Nashville. Good job so far. Let's see. Keep zooming in, keep coming in. Yeah, there's going to be several readings, but if you notice, okay, yeah, just position it over. Let's see. Let's just keep it there. I don't want to play around with it too much because there's a way that we can change that to the satellite view, but let's just not do that. Okay, so you have two. So click on, so there are your readings. So go here to where it says legends down here in the, pull the legend up, please. Okay, so so slide it over so you can see your and maybe kind of move this Okay, that's fine, just leave it right there. Okay, so if you notice, we had the Old Courtyard Northwest location. Maybe it's best that we just keep it like this. So just looking at the legend, question number one, which one of your sites had the higher surface temperature?
So from what I recall, it was the grass one, the lawn, because it was exposed to direct sunlight.
Yeah, why don't we see it? Let's see if that's correct. So just click on the two sites, your first observation. We'll click on the Old Courtyard Northwest site. The little, yeah, the orange points. Oh, yeah, there you go. Let's see what we have here. All right, so the surface temperature, well, I shouldn't be. What is your surface temperature for your Old Courtyard lawn site? You want to tell me? There it is. Isn't that it right there?
It's 20.2 Celsius.
Yes, yes. Okay, so now let's go to the other site, the other site, which was the Old Courtyard lawn. It's very good. You notice that the that your lat long, well, just click on the other one first. I'll make a point, second point about that. So what was your surface temperature there?
It's 19.8 Celsius.
Okay, so we only have, but let's look at the current temperature. Let's do that. Good job. Let's go to current temperature. We'll just add it'll be air temperature or air temperature. Get here. Okay, so so that's 15 degrees Celsius with a grass surface for the ambient temperature. Let's go back and see what the ambient temperature is for the Old Courtyard Northwest corner site. Yeah, close, yeah, go. So it's 15 and what, 19, and then so the Old Courtyard, so that, whoa, you can go back. Yeah, just click right on the point symbol. For the old, yeah. Yeah, it's the orange points, yeah, there you go. All right, so switch that to current temperature. So, okay, so for the, this is interesting. So for the grass, we had a difference of what, about 4 degrees Celsius, right? And for the concrete surface, we had a difference of only 2 degrees Celsius there. Is that what you would have expected? Would you have expected for the temperatures to be closer between the ambient temperature and the surface temperature for the concrete surface or for the grass surface?
Grass.
Really?
Would you not expect the concrete to be hotter because of GEOG?
I'm saying the difference between the ambient temperature and the surface temperature, would you expect for the surface temperature of the concrete? Well, the difference between the surface temperature between the concrete and the current temperature to be higher than the difference between the grass and the grass surface temperature and ambient temperature. Which one of those would you have expected to have the biggest difference? You know, if you were going to hypothesize, if we had a hypothesis placed for our outdoor exercise. Yeah, I would assume that the concrete would have had the largest difference, but that isn't what happened, is it? It's not what happened at all. Do you think that the time of the observation made a difference? Let's look at the time of the observation. So we had 1540 there. Let's see, well, let's look at the current 9:46 a.m. for the Old Courtyard corners. Let's see what time we got the measurement for the grass. Close that. You can close that. That is worth it, you know, hopefully. It just kind of, you know, it's y'all see what I go through every day. Okay, so then just click on that one. Let's see if at that time. It's hard to tell. Wait. Oh, 10:04 a.m. Central Time. So we had maybe a 15-minute difference between the two readings. So do you think that that would have been enough to cause us to have that much of a difference in terms of the, would that be enough time to give us this unexpected result? Just a 15-minute difference. Yes, no?
Yes, I think so.
Thanks.
Yeah, let's try, so let's roll the dice for a minute. Okay. Go up into the upper left-hand corner, see where it says layers. There, slide over to that next, see what that, don't click on it. So yeah, click on that for a second, let me see.
Here.
Yeah. No, not that one, not that. Go see those three dots, click on those three dots.
Yeah, I think that's the base map.
Click on where it says choose base map. I knew it was somewhere over there. Satellite, no, hybrid. Let's just do satellite. I don't know what hybrid is. Okay, so close that up. Okay, so close the dialog box, close the pop-up window, not that one, the other. Yeah, you can slide the Zoom stuff out of the way. Yeah, just. Oh, whoa, no, back. There it is right here. No, not there. Let me try to get back.
Yeah, I think it's the fourth tab. I don't know if you can hear me, but
I'm gonna stop the recording just for a second here. I'm gonna pause the recording. Okay, these things happen, no big deal. So, okay, I'm gonna step aside. Okay, so let's zoom in on the two sites, or just zoom in all the way now that we have the okay, well, this is interesting. So on the day that we went outside, obviously the tree cover was not like this, right? When we recorded, there were no leaves on the trees, right? Is that what we said?
Yes.
Now we were out there at what, about 9 o'clock in the morning, and what was that? The ambient temperature was around, it was like 70 degrees Fahrenheit, or like 9 something in the morning. Now you might not know this. This is just a guess on my part. But remember, I said that a surface like concrete, because of its specific heat, will, not only will it heat up faster than grass, it'll also cool off faster than grass, right? So it could be perhaps that since we were there early in the morning, the concrete surface was actually cooler because of the nighttime temperature. So maybe at night, the concrete surface would get cooler. I mean, think about it. At night, what do you think would be cooler? That's the sidewalk or grass at night? Probably the sidewalk, right? Now that might be what resulted in our having an unexpected result of a more narrow or smaller difference between the concrete and the air temperature versus the grass and the air temperature. Because what I also did not expect was for the two sites to have almost the same temperature, right? Because what we would expect is for the grass being, even though it's grass, it's out in the direct sunlight. And what was the cloud cover like that day?
No clouds.
Yeah, we had no clouds. So we had no clouds that day. And it was a bright sunny day. So we would expect for that grass under those circumstances to be warmer, but we were there pretty early in the morning. So we probably didn't have that kind of opportunity for the heat to build up. Also, what kind of radiation warms the Earth's atmosphere, long wave or short wave? It's the long wave radiation. So when are the sun's rays most intense? What time of day? Noon. When is the warmest time of day normally? Is it noon? A little bit after. Yeah, it's about 2 o'clock to 4 o'clock p.m. because there's a lag time between the time that the incoming solar radiation is absorbed by the Earth and then it's released as long wave radiation, and then that warms the Earth's atmosphere. So because we were there early in the morning, perhaps there had not been enough time for that long wave radiation to really impact the ambient temperatures. So we got very similar temperatures between those two sites. When the class comes up in the afternoon, we might see a different result. So good job, group one. Thank you very much. Hey, give him a hand. All right, that was a good job. Well, let's see, that's group one. So thank you very much, our students. Stop my share here for a moment before we bring up our next group. So we have at least one guest here, Dr. Shkowski, who is the principal investigator on my NASA grant. Oh, and so Dr. Shkowski is asking, what are the, I should share my screen. What are the features on the south portion of the path? Screen up again. Yeah. Oh, these are monuments to our fraternities and sororities. So each fraternity and sorority has a monument,
Interesting. Okay.
which these freshmen know not to go anywhere near, right? Would not be a good idea. Yeah, so those are relatively new. Notice this one was still under construction as of the time of this aerial photograph. Okay, so we will move right along. We're off to a good start here as we're celebrating. So our next group is Anderson, Prather, and Brown. Let's see. I don't know if Oh, you all use different set of data. Anyway. No worries, no worries. We won't take you through the whole. I'll ask you all a different set of questions because essentially. Next site. All right, well, let's have Anderson, Prather, and Brown come forward. Introduce yourselves. And I will introduce yourself, your major, where you're from. Your name, full name, first and last.
Oh,
Camera's up there.
I'm Jada Anderson. I'm from Nashville, Tennessee, and I'm an early childhood education major.
I am Kiera Prather, early childhood education major, and I'm from Nashville, Tennessee.
I'm Maja Brown. I'm an early education major, and I'm from Memphis, Tennessee.
Okay, so who's gonna be our pilot? Any volunteers? All right. So zoom in a little bit. Zoom in. So let's look at the data a little bit for just a second. Click on the old Courtyard Northwest site.
Is this one?
Yes, let's see something. All right. Let's see. Do you remember what? So I know that's the so we used whose data? You all use your own data for this, right? Let's go to data counts. Let's see, try to see if we can separate some of this data out. Okay, go to custom and change those dates to like 20, change like from 20, change that first one to 2023. Oh, we'll change it to the 28th, March 28th, 2023. Hopefully we can zero in, get that a little tighter. All right, boom, let's see what happens. No, hit plot. Okay, well, it looks like we only had one data count. No, wait, we had actually 10 measurements from that day for average for surface temperature. Change it to ambient temperature or current temperature. See how many air temperature. It might take a second. That's interesting. Okay, so let's go to photos. See, I don't think you have any photos. No, okay, close that up. All right, so let's zoom out again. Okay, so when we went outside on this particular day, you all did not use the app, right? The teachers did not use the app. So all those other points are students that were using the Globe Observer app. So if you notice, if you zoom in, keep going, keep zooming in. Right there. What do you notice about your points versus the points that were or versus the data that was collected using the Global Observer app? What do you notice about your points versus those? Notice any difference?
I don't think I understand the question.
So you see where your points are, right? So you remember when we were outside, all of us were standing right at those points. Look at where the observations are for the Globe Observer app. Is there a difference between where your points are and where the Globe Observer app points are?
In different locations.
Exactly. Why? What happened? You know, why is that?
I think this is when they were taking pictures
Yes.
of the sky and they were moving around.
No, nobody was moving around. Where there was anybody all the way over there by Boswell?
They were like.
No, that
changing
wouldn't.
direction in pictures.
Remember, I mentioned something about the GPS receivers in your mobile devices. Oh, we can have a question.
Could it be the time?
No, it's not the time. Remember I said something about the GPS receivers in your mobile devices?
They're like 300 feet off or something.
Exactly, they're not accurate, and this clearly shows that. This clearly show, because how did you all, where did you all get the latitude and longitude for your point?
Did you tell us?
What do we use to get the absolute locations for your points?
The app.
No, we didn't use that. Well, you entered it with the app, but the original data was collected with what? When y'all were out there, I was out there. Remember?
We got the longitude lecture from you.
Yeah, we got
Okay, great, I
a
see.
screenshot of it.
Where did I? Yeah, but I mean, there were people who collected. No, wait. You all collected the data. So you remember you
Our
were in groups.
students,
Yeah, or
And
Okay, so
we
what were
used
your
the-
students using to get the lat long?
my students were using the app.
No, they didn't. They had something else. Yeah, they used a GPS receiver. Remember, there was one of your students used a GPS receiver. You took the lat long from the GPS receiver, and then when you went into the either the app or the desktop data entry, you use the GPS receiver's lat long, and that's why you have a much more accurate location than if you just use the app. So that's just something to keep in mind when you all become teachers and you're using Globe. That's why you don't necessarily want to rely upon the app to get your location, because you can see what it looks like. They're all over the place. And this clearly shows that offset. Let's see. Like zoom in on the Old Courtyard Northwest site. Okay, zoom in and click on it. Yeah. And let's see, let's look at your clouds measurement. See what we have here. You scroll down. You know what? This is odd because wait a minute. Make sure. Let's see. Yeah, you got 18 different. Oh, so you actually, whose is this? If somebody recorded the barometric, yeah, we got the barometric pressure and deep blue sky, no clouds at all. On this particular day, which was disappointing for me. But I don't know, maybe Dr. Strakowski could help with this. I remember in some cases that, or maybe it's only with the teachers app, that in some cases, if you use, no, that's not true. But I remember getting the cloud match here. Wait a minute, no, it's right there. See, it says open a new window. Yeah, there it is. It's right. See, it says open a new window. See, it says, I know it was there. Yeah, click right on that. Click right on that. Okay. All right, so let's take a look at our satellite match. And well, yeah. So even though this is like the worst type of day that you want to take your kids out and do cloud observations, that's why unfortunately we had to kind of have a nailed down day. But when you start teaching, if you pay attention to the weather and they say that there is either a cool front coming through or anything that results in low pressure, that's the day when you should get ready to do clouds. Because remember, low pressure is represents instability in the atmosphere, and that's when you get clouds, right? If it's high pressure, like it was the day that we were out there, yeah, close this up for a second, just real quick, close the cloud observation, really no.
I can't
Yeah,
see.
you can slide that, you can slide the zoom things in the way of it. Let's see. Don't do any of this. But don't worry about it, right? Jeez, how can we get out of this? All right, hit I'll do it.
The X in the upper right corner.
One thing that's a pain in the neck is Zoom stuff gets in the way. Okay, I didn't want to close. Let me see, close this. We're going to just switch back to there. Okay, yeah, this is interesting that I don't know who actually recorded the barometric pressure went above and went. Wait a minute, let me get the screen share back up. Okay, one of the students actually recorded the barometric pressure, and so, man, yeah, 1,008 is not necessarily 1,008 millibars is, I guess that could be considered on the lower end of high pressure. Like if a hurricane comes through, then you get your millibars might drop down to like 980, right? That'd be very low pressure. But 1,008, that could be relatively high pressure, which would explain the cloudless day. So whoever collected that barometric pressure reading, I don't think we were supposed to do that, but you know, so we do. We go beyond and above what's expected. We also collected wind data, and so if you notice that in some cases, well, I won't get into that here. That's getting too complex. Thank you very much. Good job, as we will continue with our celebration of, or observation of GIS, Earth Week. Moving on to, yeah, we got the pressure from the Kestrel meeting. Yeah, so. All right, so let's move right along to, I guess we don't need the globe up here anymore. Good job, globe, pre-service teachers. Good job today. Thought we'd have more, yes, but that's okay. All right, so the next group, now we're going to get to the ArcGIS Online assignment. And so just for our viewing audience, share the screen here. Okay, so the assignment that was completed by the next two groups was to take the take the atmospheric protocol data and convert it into ArcGIS Online format. And then, of course, so these are the steps, boom, boom. So they had to enter the data into a spreadsheet and then they took the spreadsheet and converted that spreadsheet into ArcGIS Online format. And then they were supposed to create a map that overlaid the surface temperature with the ambient temperature. Kind of tricky to do. These students have never used GIS before, so anyway, and then what was most important was the analysis, you know, what did they observe, what were the results of the analysis, and then they were supposed to oh, I forgot the Globe students, you got away with it. I was supposed to they were supposed to answer some questions related to the urban heat island effect, which I forgot. But you all get it. Got lucky. Older Dr. Pete Blicker. So let's see. I think this is Coleman's group. So this just should be the right group. Yeah, so you got Shoemake, Cantuli, and Coleman. Pretty sure that's your map. Let's see. So group 3. Coleman, Cantuli, and Shoemake. So just introduce yourselves, your name, your major, where you're from, and then we'll get moving. The camera's up there.
I'm Caleb Shoemake. I'm from Atlanta, Georgia. Oh, my.
Major?
Oh,
Yeah,
economics. I'm an economics and finance major.
My name is Mysore Hensuli. I'm a psychology major and I'm from Nashville, Tennessee.
My name is Sydney Coleman. I'm from Detroit, Michigan, and I'm a criminal justice major.
Okay, who's gonna be our pilot? It's gonna be Coleman. All right, so now notice that we have, this is, okay, zoom out a little bit. You might want to slide that Zoom window out of the way. Kind of slide it, yeah, there you go. Okay, zoom out a little bit more. Zoom in, zoom in, zoom in, zoom in. Okay, so we're gonna have some teachable moments here today. So don't worry, I'm not trying to embarrass you in front of Dr. Sikowski or the rest of the world. Let's see. So obviously something is not right here, but it's fine, it's fine, it's fine, it's fine. So, but let's just first look at the Old Courtyard Northwest site.
You want me to zoom in?
Yeah, just click on it, just click on it. Okay, so this is Miss Prather's data. And so scroll down. And so scroll up. So yeah, so once again, we have our average surface temperature at 19.9 degrees Celsius, and then the current temperature using the liquid field thermometer at 15 degrees Celsius. So see where it says 1 of 2, hit that arrow at the very top. See what else is here. Basically, oh wait. It's interesting. That one's different.
This is not the map that I did. I don't know if this is the one that Caleb did, but
I got it from, well, teamwork makes the dream work.
No, that's the same level. It's like the papers, when you download, like, put the information in, that's the stuff that will come up.
So you're saying you have another map? Not this one? Okay, we can take a pause for the cause. Let's see.
Yeah.
Pause recording for a moment. Okay, we're back. This recording is resumed, and go to screen share. Okay, so our pilot is taking over again. This is group 3. And yeah, this is a little bit better. So, but there's still some errors. I don't know if they're even possible to be corrected, but let's see. But we have to, this is about the data, right? Okay, so now click on the, zoom in a little bit and click on the Old Courtyard lawn site. It's a little bit better. So this is Anderson's data. And okay, so you got surface temperature, but there's no current temperature. Okay, so we've got a surface temperature but no current temperature for that site. Well, close it again. Maybe there is. Maybe there is. Close that. Oh, close it all the way. Close it all the way. Yeah. Zoom in, zoom all the way in. Let's see. Click right on the white dot. No. Okay, close. Oh, wait. Hit that little arrow. Let's see. To no. Don't worry. Okay. See the little dot that's off to the left a little bit? Yeah, it's just a stat. No, okay. Oh, let's close that. We're gonna do this is what we call a teachable moment. Go to content. So now we're gonna look into our so this current, yeah, click on that, open up the data table. This is where we can find potential, I don't know what's happening here. So scroll through your data. So you got scroll to the left, other left. All right. So you have good. You have all the data is there. Cloud types. Yep. Scroll across. Wind speed. Good. No characters in. I see what happened. You just forgot to put the current temperature in the spreadsheet. Go to the other layer. Yeah.
Let me show
Open that up. Scroll across. All right. Well, no big deal. Close that up. Just have some missing data there. But go to Legend again. Go to Legend. And so click on the Old Courtyard Northwest site again. So we have a surface temperature of 19 degrees Celsius. So now click on the lawn site. Surface temperature of 22 degrees Celsius. So is that what we would normally expect?
No,
What would we expect? Probably the exact what?
opposite.
The opposite. But perhaps, what do you think might have resulted in this result? So now we're using a different teacher's data, right? So what might have happened here? Well, how might we've got these two unexpected results? The grass is warmer than the concrete.
I would say because the grass had more direct sunlight than the
Yeah, exactly.
sidewalk.
Exactly. And notice we had no clouds. Let's look at the wind speed on the grass versus the concrete. So we had 1.4 meters per second on the grass. What do we have on the concrete? Wind speed is less on the concrete surface. Now, I'm just speculating here. I mean, you probably wouldn't know this. So what happens to air when it gets heated? Does it rise or does it sink? So it rises, right? So where will we have rising air between these 2 points? On the grass or concrete? Which one was warmer?
Grass.
Where would we have rising air?
Grass.
Yes, on the grass. So what happens in what we call an urban microclimate is that you have higher pressure where the concrete is and lower pressure where the grass is. So it makes sense that we would have higher wind where the grass is, where the air is rising, because you have lower pressure. What's happening is the atmosphere is trying to balance itself out. So if you have high pressure here and low pressure here, it's going to try to get to this. And so that's what wind does. Wind is when air goes from a high pressure location to low pressure because nature wants to be in balance. And so that's called advection. It's the horizontal motion of in the atmosphere. And so when wind happens, it goes from a high to low pressure across what we call a pressure gradient. So that makes sense that we would have higher wind on the grass at that particular time on that day. Okay, so you all are not going to get away with not answering the. So from what you did here, what did you learn? How did this show you? How did this give you a greater understanding of the urban heat island effect? Doing this little exercise. Well, first, what is the urban heat island effect? I want to ask you that. One of you all wrote a really good answer here.
What I wrote.
Plagiarism. No, I'm not.
No, no, I just.
Yeah, come on. It's urban heat island effect.
Yeah.
Is the urban heat island effect a good thing or a bad thing for our health?
It's a bad thing.
Yeah, it's bad. It's pretty bad. But so I mean, what about this exercise might have taught you anything about the urban heat island effect? Like how it happens, dynamics. Just think, just take a deep breath. There's no pressure here. This. Okay, let's try to think about this. What could we do? Well, go back to the other map. Let's look at the other map. See the tab in the top? Yeah, let's see. Now this map isn't accurate in terms of location, clearly, but the database is correct. So we have on the concrete surface, we have a 4-degree temperature differential. Go to the what should have been the grass surface. We have it's a little off. I guess that's the other tiny little dot. I think that's supposed to be, yeah, that's the lawn site. Scroll down. No, not quite. It's about the same. That's interesting. But the grass surface has just a slightly. What do we have? The difference. What's the difference for the? Go back to the surface. Sorry, this is senior moment here. Scroll down. Maybe about almost 5 degrees, and the other one was 4 degrees. So we had a slightly greater difference between the surface temperature and the current temperature on the concrete. But so close that dialog box. Okay, so if we were to say, do this exact same experiment in say July, not even July, maybe June, what might be different?
Increased.
Yeah.
What might be different? What might change between the time you were out there in June that might give us perhaps an even more or result we would expect? I don't know. Okay, what is one thing that might change about when we were out there, other than temperature, not obviously the temperature, but there's something else that might change, not that might change, that will change between March and June that would perhaps affect our results. What might that be? Between March and June, what might be different? What might change? Okay, look at the image. What did the image look like that when we were outside? Did it look like that? No. What's different about this image and when we were out there? The leaves. We have more leaves on the trees. So if we were at full leaf out in June, let's say, even though the temperatures might be higher, how might that affect the temperature of the concrete?
It might keep it cooler.
Yeah, it will be cooler. We've done this experiment later on. And as a matter of fact, if we have later on today, when we have the 1245 class, the results will be the exact opposite. If when we have leaves on the trees. Okay, well, I'll let y'all slide. That was kind of, I'll just go with what you wrote here. Let's see. One of the highlights was we were talking about mitigation strategies, and says you all said, some of you all, well, it was a whole team. The team said GIS could help you urban heat island mitigation strategies to map out whether the strategies actually work. So we could actually use satellite imagery and GIS and this type of symbology to know the differences between city surfaces before mitigation and of course city surfaces after mitigation. So thank you very much, group 3. No applause, no snap. Snap, with the 900 clap. All right, that was a good job. We had 2 different maps there, but teamwork makes the dream work. One map was accurate in terms of location, one map was accurate in terms of data. Let me look here at this. So notice, yeah, so that happens. I mean, we always have to be very careful with data entry. Yeah, so notice current temperature and surface temperature there, but then this data table is incomplete. But anyway, always gotta do that. End of the day, but this group did a good job. Oh, yeah, but luckily, you all, whoever did this, correctly entered the surface temperature and average temperature data here. Then over here, notice that there's a problem. Got characters, but luckily, whoever did the data entry self-corrected. All right, so on to our, let's see, who's our next group here? Zoom, let me see this. Thing, the next group, and I think we have a solo dolo version. So our next group is group 4, which is Womack, SoCo, and Johnson R. And I'm assuming that the map that I pulled up, you all's map, share here just for a moment. Second, to get back to your map. I think this is you all's map here. Oops. Oh, wait. Okay, so we have next group 4, introduce yourselves, and the camera's back there. Your name, your major, where you're from.
My name is Sanaa Womack. I'm from Atlanta, Georgia, and my major is studio arts. My name is Ryan Johnson. I'm a civil engineering major from Livonia, Michigan.
Okay, so let's see what we have here. So I'm gonna try something with this group. First, let's click on the old courtyard, northwest corner site first. Let's see, so this is Brown's data. And that looks like this, yeah, yeah, click that arrow, let's see what else is over there. We got a few, yeah, the little arrow there. And we have Nori's data. And then one more time. And then we have Jones's data. So this is fine. So notice that the 3 teachers had different results, which is okay. Because speaking to the teachers, what we would do normally is if you took your students out and your students got different results, you would take your students' data and average it together to get your final result. Okay, so let's see. So we've got 4-degree difference between the current and average. So that was a miss. Yeah. Oh, what? Anyway, I'm not. Just go to the next one. How did Vic Jones and Miss anyways? This makes sense. So then we got a 2-degree Celsius difference here, and then go back
To Jones was the first.
So we get 19, 4 degrees Celsius difference there. So let's see. Go to the next one. Hit that arrow again. It's a senior moment here. 15, and we had 18. Next one, and then we had, this is good, this is good. And we had 16. So this just shows you the variety of results that we can get in the field, depending upon who's using the instrument and so on and so forth. Okay, close that. Let's go to the old courtyard on site. This should be interesting. Okay. So 23 degrees Celsius there, 16 degrees. Okay, scroll across. Yeah.
Let's scroll down.
No, you're good. So this one we got 17 degrees Celsius. Wow. And that, yeah. Okay, go to the next one. And the next one somebody, what's wrong here? What's wrong there? What's going on here? What's wrong with that number? Yeah, okay, so let's does anybody convert that to degrees Celsius for us, please? Anybody in the audience or on the stage? Quick. Just take 2 seconds. So we have 18.4 degrees Celsius. We got it. 18.4 degrees Celsius. And go back to the next ones. 18.4. Then we have we have 17 degrees Celsius. And go back again. And then 23.6 degrees Celsius. So what do y'all think about the data there? I mean, that's a pretty wide range of temperatures in terms of surface temperature. What might have happened there? Or let's put it this way, which one of these do you think is closest to being correct?
What did you say this one was?
That was about 18.4 degrees Celsius.
It's between the last 2.
So you think because we got 2 that were closer together that maybe this one is the outlier? Something went wrong here. Let's look at the current temperature. So we got 16 here. What was the next one? 13. And then 18. Let's go back to the old courtyard northwest point. So that's 15 current temperature. And then we have 18 current temperature, and then 16. I don't know. I mean, but from a teaching standpoint, there's nothing wrong with this. You know, there's nothing wrong with this. They should be closer together. And I know I was keeping my eyes on you all with those liquid field thermometers, and everybody seemed to be managing liquid field thermometers okay. Maybe when you were using the infrared thermometers, I don't see how you could not hit grasp. I don't know. This is just interesting. So let's try something. Let's try one more thing. Go to content. Click on, let me see what's going on here. Okay, click on that layer. Let's see. Click on the symbology. Yeah, click on right. Okay. Let's see. Go to options. I'm gonna try to fix your symbols. Maybe, I don't know. It might be too much. Might be too far off. Go hit op. Let's see. Go. Geez. I don't know what. How do I fix this? Go to options again.
For this one?
Yeah, click right on options. Okay. Click on symbols. Wait. Cancel that. See where it says theme?
So the.
Theme, where it says theme?
Up there.
Up there.
Where high and low is.
Yeah, right. See, go down.
Oh, I see, yeah.
Okay, click on that. Oh my goodness. Go to divided by. No, don't do that. See, okay, click OK. Click on symbols again. Okay, click on that circle. Hit OK. Scroll down in that window in the yeah. Yeah, I was trying to fix your symbols. I mean, they look okay, but I guess they're okay. It's just in the legend, it looks kind of weird, but you did a good job. You got the locations correct. You got all the data in there. It's just the symbology is very, very difficult to read, but it's okay. It's okay. It's first time using GIS. At least you got the symbols on the map. Let's go to your data table. One more thing, go to details, top. And then let's open up your data table. Oh, yeah. No, not that. Yeah, okay. Scroll down. Scroll through your data table. Yes, you got all 3 teachers' data. Yeah, looks good. The most important part of GIS is that I, which is information. So you got your information, good, no, scroll down through there, yeah. Good. Yeah, you guys got all the data in there. So yeah, I gave your group 3 teachers. So you got all the data in the database, it's clean. So as long as your database is good, if I had time, I would pull this into the map and just do the correct symbology, but it's too far gone. I mean, it's just it's fine. Good job, group 4. And I think you have a solo person here, or we're done. Not done for the day. Done. All right, so thanks everyone for the first iteration of geography, or say geography of Earth Week at Tennessee State University. Give all the students a hand. Oh, Wait a minute, oh, there's another group. Sorry about that. Jones, Burston, and Lambert, you have a map?
That was the map that you were using,
Wait, which one?
or, the one that says, geography GIS 4/5.
This is your map?
Yeah.
You
I
didn't
was,
say
when
anything.
you were holding my hand up to ask you what the issue, what's wrong with the map.
Yeah, what was wrong with it? Everybody wondered.
Alright, come on down, we have another group, I didn't know. Have to. Green share, we have surprise guest. Let's see what time is it. So this group is group 5, sorry, I forgot about y'all, so you have Lambert. Or introduce yourselves, name, camera's over there.
I'm Aaliyah Lambert, I'm from Memphis, Tennessee, and I major in mass communications.
My name is Corey Jones. I'm from Memphis, Tennessee, and I'm a biology major.
My name is Joy Burston. I'm from Atlanta, Georgia, and I'm an architecture engineering major.
So this is your map.
Yes.
Anyway, so we'll click on. What should we do here? So well, let's just look in, let's go in, let's see what happened in terms of your data tape. Let's see what time is it? Let me just. Anyway, we can't fix it now. But let's see what we could do to fix it. So go to content. And yeah, click on that data table. Let's see. You really can't, yeah, I don't think we're gonna, yeah, because see the lat long is truncated here, so I can't really see exactly. Wait a minute, wait. No, that's just, yeah. So let me ask you a question. That is the error. So you know that second point is not in the right place, right? The old courtyard lawn site should be where it is. Yeah, it should be actually, so that point should be over there, right? So is that a latitude or longitude error? Is that a latitude error or a longitude error? Think. It's a longitude area, north-south. So somewhere at some point, probably what happened is, okay, let's see what the offset is. So close this dialog box and go to measure, go to the measure tool and make it feet. Well, first make it a measurement. That's square, you got to square it. Yeah, let's make it feet, even though it should be meters. Okay, yeah, click there. Well, click where the well, not there. Just start over. They go from the wrong one to the correct. Yeah, so just close that. Okay, yeah, all right. Well, just close the whole thing out and start over. Okay, good. Boom, right there. Feet. Okay, now click it right there, and then drag it to about where. Okay, so yeah, right about there is where it should have been. So it's off by 137 feet. 137 feet. So let's see. So each whole degree of latitude is what, 69 miles. So 1/10 of that would be 6.9 miles. 1/100th of that would be about a half mile. 1/10 of a thousandth would be, let's see. So if we take 69 miles divided by 1,000, that's 6.69 miles, which is about 2,500 feet or so. So a tenth of that would be 250 feet. So I'm willing to bet that if we pulled up your data table, you transposed a couple of the numbers you can't see it there, your raw data table. Yeah, let me take over. Let's just see. I'm just curious. It's just me being curious here about what's going on. Don't mind me. It's just my own scientific mind working here. So let's go into here. And let's go to here. So we're gonna pull up the raw. Let's see where the error is. That's all we can probably do right now. This is all learning. We're all learning here. You know, it's all about learning. And let's see. So do y'all remember whose data table you use? This is it. You use this table, okay? So this sometimes Excel is easier to deal with. All right, so we download this. Let's see. Come on now. All right, here we go. All right, so let's explore. So remember, the I in GIS is the most important thing. So let's look. So we know that we have a longitude error perhaps. And I'm trying to see what might have happened here. I can't tell. We have to actually go, well, you know, we do have, let's, I'm even more curious about this, because we do have your raw data, right? So whose data were you using here? And this is all part of doing science, okay? You make a mistake, you have to go back and dig and dig and dig. You're using Prather and Smith's data. There's here, okay, here's Prather. And aha, there's where the error is, right there. So that's 8303 for longitude, 36, let me see, is that right? Is that the same? Yeah, 148, wait, that can't be right. Okay, we've got no lat long here. Okay, so the longitude error was with the old Courtyard lawn site. So here we go. We got to find Prather and Smith's old Courtyard lawn site data. Maury, Prather, Smith. Negative 803,891. That's clearly not the same. So it's somehow in transferring the data from your raw data paperwork here, this number is, it shouldn't be that close together. So it happens, that happens, you know, you're in a hurry. I don't know how that wound up being the other number, but this is the correct number. I bet if we were to put that number, is other number correct? Is the launch latitude correct? Yeah, 36, 16489. It's all wrong. And anyway, but you know, these things happen. Don't worry about it. So we kind of did a forensics deep dive into your data. But if you were going to fix it, you would that's how you would do it. You have to go back into your raw data table figure out what went wrong, and then bring the layer back in with the correct data. You can't edit it here. So thanks very much. We have a couple more things, one more or two more things to do. Thank you very much, group 5. Then we can go another time. Okay, so thank you all. I'm going to thank you, Dr. Kowski, for stopping in. And see some things in the chat. So he had the same problem with lat long with students. With PhD students. So it happens. I mean, people make mistakes. It's not a big deal. A teachable moment.
See you later.
Going to end the whole show here. Thank you very much for our first iteration of Earth Week at Tennessee State University GIS.